we will start right on time with the second talk of today. So with the talk of Emma Ward. She did her PhD at the Donders Institute in the Netherlands, and she recently started a postdoc in Berlin at the Freie Universität. And her main interest is how expectation influence perception and how that develops in infancy, and how that changes in between autistic and non-autistic people. And we will are going to hear more about her interesting research. So please, Emma, the floor is yours.
Thanks, Alberto. Hi, everyone. I'm just making sure that I'm sharing the correct screen. Okay, can you see the slides now?
Yeah.
Okay, perfect. All right, so as Alberto said, I did my PhD at the Donders Institute, and this is work that I did there along with Jan Buitelaar and Sabine Hunjes. And essentially, my PhD was about evaluating predictive processing accounts of autism. And these are theoretical accounts that claim to unify all symptoms of autism and explain the foundations, the cognitive mechanisms behind autism by saying that autistic individuals assign higher precision to their prediction errors than non-autistic individuals. So essentially that would mean anytime somebody encounters an observation that does not match their model of the world, an autistic person would be more likely to update their model than a non-autistic person would. And this has a few consequences for perception. So incoming sensory input should therefore be seen as more novel by autistic participants, and experiences that bias perception in non-autistic individuals should bias autistic individuals less. So therefore we use adaptation because we know that we can bias perception in non-autistic individuals. And adaptation is essentially the phenomenon that exposure to stimuli on one end of a continuum biases later perception away from that end. And it's been shown to be reduced in autism in some studies, but also equivalent in autism in some studies. So we were curious. And as far as we know, there's so far nothing about the neural mechanisms underlying this in autism. So we used a similar task. And here's an example. So what you see is a continuum here from Ben Affleck on the left to Heath Ledger on the right with evenly spaced face morphs, and the central face is exactly half Ben Affleck and half Heath Ledger. And what we're going to do now is expose you to one end of a continuum. So we're going to look at the face all the way on the left, which is Ben Affleck, for 5 seconds. So if you look at that one with me, 1, 2, 3, 4, 5, and then look at the center, it should look to you more like Heath Ledger now. Whereas if we look at the right one, so we're going to look at Heath Ledger now for 5 seconds, 1, 2, 3, 4, 5, and then look at the central face, it should now look more like Ben Affleck. So nothing changed about the physical stimulus, but your recent experience biased your perception. So if prediction errors are weighted more highly in the autistic group, they should experience this shift in their perception less. So they should show less behavioral adaptation in their responses and less differentiation of ERPs to adapted and unadapted stimuli. And we tested this not with face identity, like I just showed you, but with gaze direction, because this is also a nice continuum. And we have very clear neural markers of gaze direction and face perception. So, and these stimuli have also been used before in behavioral studies with autistic kids. So essentially what they saw was a familiarization in block 1 of gazes of 0 degrees, which is directly looking at you, or 5 degrees to the left or 5 degrees to the right. And then they had this long exposure like we just did in the second block with one very extreme gaze direction. And then in block 3, they were reminded of that very extreme gaze direction and again saw gaze of 0 or 5 degrees and asked to respond which way the person looked. So it looked something like this for them. So in block 1, they would see a trial like this. First, just the face, and then after the offset of the face, the question, which way did they look? And they responded with a button press. And then another one, which is 5 degrees. And after the offset of the face, respond with a button press, which way did they look? And then in block 2, they got this very extreme gaze direction. And then they were exposed to this for a few minutes. And then in block 3, they again saw the original faces with smaller gaze direction and were asked which way they looked. And because they were exposed in block 2, remember, to this extreme gaze direction to the left, they should perceive all of these faces after that as looking less left because they're biased away from that end of the continuum. So we did this with 55 teenagers, 26 autistic kids and 29 non-autistic kids, and they were all aged between 12 and 18, and the mean age of both groups was just a bit over 15. The groups didn't differ in their short form IQ scores, but they did differ in their social communication questionnaire scores, which is nice because that's a measure of autism symptoms. So on this continuous dimension of autism symptoms, our autistic kids were higher. And for the behavioral analyses, we used ordinal logistic multi-level modeling. And for the ERP analyses, we used cluster-based permutation testing. So I will first just talk you through the results of the non-autistic kids and then add the autistic kids after. So if you see here just the accuracy in block 1, so that's before they were exposed to the adaptation effect, you see accuracy was between like 60 and 100%, and that's actually quite good. I don't know if you noticed that these 5-degree gaze directions are quite subtle, so the kids did very well. And in block 3, post-adaptation, they were less accurate, but that makes sense because we wanted to bias their perception. We wanted them to perceive it not as it really was. And then if we add the autistic kids in blue, you see there are almost no differences at all. So the autistic kids did just as well as the non-autistic kids. And then if we look at the actual adaptation effect, here you see the response that they gave. So did they say that this person was looking in the direction they were adapted to, the direction they were not adapted to, or direct? So we've now normalized over left and right because some kids were adapted to left and some kids were adapted to right. And you see before they're adapted, they don't differentiate between which they've been adapted to and which not, which is good because it hasn't happened yet. They're about the same, and they're more often saying that the people look direct, which makes sense because the angles are quite low. And then after the adaptation, you see exactly what we expected, that the direction they're adapted to, they respond less because they're biased away from that direction. And then they respond much more to that those gazes are direct because they're quite subtle, but they're just shifted. And if we add in the autistic group in red again, in blue again, we again see almost identical results from the autistic and non-autistic kids. So there's no difference here between groups in how they respond to the adaptation. Okay, and then if we look at the ERPs, essentially what we were expecting was that there would be specific repetition suppression to the direction that people were adapted to after the adaptation. So here in green, we expected smaller responses for both directions because as the experiment went on, we get habituation anyway, but more repetition suppression to the one they were adapted to. And this was just an example, but if I show you now, the autistic group at the top and the non-autistic group at the bottom, you see neither of them show that pattern. So there's no differences for either group between adapted and unadapted, and no difference between the groups. And this is a mean of all 10 parietal and occipital electrodes, and that's based on a previous paper that we wrote, but sorry, but it's also the same pattern of results if you just look at P7 and P8 based on some other adult studies. So it really just doesn't seem to be there. And then we were also interested in general habituation. So if all incoming sensory input is perceived as more novel to autistic participants, you would expect they would habituate less in general. So we just took all responses from block 1, subtracted all responses from block 3 and plotted the difference wave. And again, you see autistic kids in blue and non-autistic kids in red. And the bold part is significant clusters. And you see that both groups habituated, but the groups did not differ. So at the bottom, we just plot them next to each other and there's no significant clusters there. So we didn't see any group differences, which is inconsistent with predictive processing accounts of autism. And other findings tell the same story. So other papers that I have written and some colleagues with teenagers and younger kids do not find any evidence of predictive processing accounts of autism. And then, of course, this is really important for multiple reasons. So any account of autism should also address development, because autism is a developmental disorder. But on the other hand, I think any kind of general cognitive or neural mechanistic claim about how the brain works should also apply to younger kids. So a developmental perspective is important for predictive processing in general and for predictive processing accounts of autism. So it seems like the theory needs to be adjusted. And like one promising avenue that I can see at the moment is maybe taking into account different precision weighting at different levels of the cognitive hierarchy, which is stuff that people in the schizophrenia field are really working on a lot at the moment. And it sounds really interesting, but hasn't really made it over to autism yet. But I think in general, if we want a theory to be able to explain all of autism, we need to really make sure that it can address different domains, different ages, and that's not happening yet. So that was what I have for you. Does anybody have questions?
So thank you very much, Emma, for the very, very nice talk. So let's see if we have questions. It appears that we have one. Yeah, from David. Could it be that the lack of differences between groups is related not enough statistical power? In the last peak, there seemed to be a trend. Perhaps Bayesian approach could help.
I'm assuming in the last peak, you mean something about the ERPs. So yeah, in a previous paper, I did this exact paradigm with 2-year-olds who have autism in their family or not. And then we obviously didn't have button presses because there were only 2, but we did use Bayesian statistics on the ERPs. And essentially, I was not really happy with how we implemented the Bayesian statistics on the ERPs and therefore didn't do it here. I would be happy to do it, but how we did it then was I used JASP and then I had to take just one value from the ERP. So I took a peak and then did a t-test between the groups. I would be really happy to do it if you know anyway, because now we use this mass univariate testing on the ERPs, comparing every time point. If you would know how to do Bayesian statistics that way, I would be happy to do it.
And David is referring to the last image, he says.
The last image, oh, the habituation. Yeah, so indeed, this is the only place in the 2-year-olds that we did see a difference between the groups. So if anything, I think we see more of the habituation thing, but it's in the opposite direction than we would expect. So there's more habituation in the autistic kids than the non-autistic kids, and that does not fit with predictive processing, which says there should be less habituation in the autistic kids. But that's also the direction that we saw in the 2-year-olds. So if that was also here, then that would be really interesting. What I would say about the power is that at least with the ERPs, at least we do have very nice small error bars. So I think we have relatively clean data.
Thank you very much. Then we have other 2 questions from Benji and from Bianca. They are kind of related. So first of all, they say it's a very cool work. And they are asking if the choice of so I direction, gaze direction is kind of implicated, or since, well, we are talking about autism disorder where social impact is kind of related. So maybe the choice of eye gaze as a stimulus could have an impact. And so do you want to say something about it?
Yeah, thanks. So actually, I really wanted to use non-social stimuli because I think if it's more domain general, then it's more interesting to me. But my supervisor convinced me very well by pointing out that we have really good known ERPs for face and gaze discrimination. So I think there was a really strong reason to use these stimuli specifically, also because they had already been used in a behavioral study with autistic kids. But we did eye tracking because we knew that it might be a problem that the autistic kids might not look at the eyes and then they would not adapt. But in fact, our lack of difference between the groups shows that the autistic kids were looking at the eyes, right? Because they were influenced by the gaze direction. But we did compare the groups, and the autistic kids made fewer fixations to the area of interest around the eyes, and less of their fixations were to the area around the eyes. But they did spend about the same amount of time looking at the eyes, or they didn't differ in the mean duration of the fixation to the eyes. And apparently, even though they made less fixations there, it was enough to get the information because they were indeed biased in their perception by information that was only in the eyes.
Perfect. Thank you very much. So we have other questions, but unfortunately we are kind of out of time. So thank you very much, Emma. I encourage everyone who has a question left to reach out to Emma on Twitter or at her email address. So thanks again.
Thank you.
And then we can pass to our